think I've used it that I can remember. Okay, for the recording for posterity, this is a meeting that we're recording for SIG Autoscaling to discuss DRA and Karpenter. We've got Jason and Alima. Maybe some other folks might join because I pasted the link publicly in Karpenter Slack. But we want to just have an introductory conversation about maybe first steps in terms of design and RFC work, and try to get ourselves kicked into gear here in the near term. So the first thing I'm going to try to do is just share the images. I think we've looked at them a little bit, and maybe that will help us to talk through them. And like the first thing is like, is this the appropriate amount of omitted detail? Because we're obviously, this is super high level, and we don't want to try to guess every little detail. I think we got to do these one at a time. That's unfortunate. All right. So I'm
Jack,
not sure I can.
I can share.
Go
I have
ahead.
both of them pulled up like side by side, like on draw.io, if that's it.
Okay, go for it. Why don't you do that? Yeah. I've got them as separate preview files on my Mac, and it's going to require me to switch the screen share every time.
Yeah, let me.
Do you need me to give you permission?
Mm,
Oh,
no.
good. You can do it. Okay, cool. All right, great. Let's start with cluster autoscaler because that one's a little easier. Okay, beautiful. So basically, this shouldn't come as a surprise to you, Jason, but what we want to communicate here is that when you're running cluster autoscaler on your cluster, the expectation is that your cluster topology will be sort of laid out in advance, and then you point cluster autoscaler to one or more node pools that are within that topology, each of which serves some distinct purpose. And you can sort of infer from that description that each node pool is homogeneous, sort of acting, building replicas according to like a static node recipe. And so in terms of DRA, what that means is that when pending pods come into the cluster that reference resource claims, which is the new sort of DRA primitive for defining a device scheduling constraint, for one or more devices, I should say. Cluster autoscaler needs to be able to introspect its existing node pools and find out which of those node pools correlates with the devices that are being requested. Devices are defined in resource slices. So that's what's in this slide. So the device thing that I'm referring to is a little bit the underlying scheduling primitive of a device sort of opaque in these slides, but I didn't want to get into too much detail. But essentially, the base case is there's a one-to-one relationship between a node and a resource slice. And within that resource slice, you get information, you get device information that correlates to those nodes. So cluster autoscaler's responsibility is to be able to, for each node pool, sort of evaluate, do the nodes in this pool come with resource slices? And if so, do the devices in those resource slices fulfill the constraints that this pending pod declares? So it kind of does the evolution of cluster autoscaler for DRA was really kind of as simple as extending the existing way that it introspects nodes and then is able to carry out simulations to include resource slices as a sort of first class. You could almost call it a first class attribute, metadata attribute of the node itself. So for each node pool, because they're homogeneous, if any one node in that pool has a resource slice, then you can just assume that they're all going to have resource slices. So you can make that initial determination really easy. Like, does this node pool, is this a DRA sort of capable node pool? Do you have any questions about any of that?
No, I don't think so. I guess just one clarifying question. I believe I know the answer, but there's no scale to zero support then with, or scale from zero support then with CAS, right? You need to
Well,
have
not
an
not
initial.
yet. It could be because the way that cluster autoscaler defines scale to zero is somewhat like a super proto Karpenter. Like I think it's been around for a long time, and it's so it define cluster autoscaler defines some sort of simplified metadata data structure that describes what a node's going to look like once it gets scaled out, and that can then be used with the by the underlying provider, which is responsible for doing the provisioning to provision a new node from scratch. So it's slightly different from provider to provider. Like the cluster API provider compared to the AWS or the Azure provider is going to do scale to zero slightly differently. But there is a notion that you can describe at a high level to aid the provider in order to build a real concrete node. And so there is some loss in like feature fidelity when you're doing scale to zero. It only supports a few of the overall types of features because that like simplified representation of what a node's going to look like sort of omits a whole bunch of interesting stuff. So that theoretically that could be implemented in cluster autoscaler, but it's not. So there
Got
is a sort of basic scale to zero capability for things, and this fulfills the I think the most common requirements of most cluster autoscaler users, where they're like, yeah, node pool with 4 cores per node, and 16 gigs of memory per. That's the kind of thing that you can sort of hoist into a simplified data structure, which the provider can then use to build. And frankly, most providers hoist out things like the actual VM flavor, like so the EC2 instance or the VM SKU using Azure terminology.
Okay, yeah.
I don't think that there's much DRA. I can't speak authoritatively to the scale to zero question, but I think it's fair to say that that's not something that we can assume is there for DRA right now.
Okay.
Especially considering the flexibility that DRA introduces, it's fair to assume that that's not going to be a fully achievable thing for cluster autoscaler.
Yeah. The main reason I was wondering is because with Carpenter, you can essentially think of every scale up as potentially being a scale from zero since we don't know the
100%.
shape. So yeah, just wondering if there was any prior art there we can lean on.
Yeah, not for. I don't think for DRA. I can follow up on that though.
Yeah. All right. Sounds good.
Yeah, but so if we go over to the Carpenter case, uh, it's different in the sense that, as you point out, Carpenter carries a much more sophisticated data structure definition to describe what nodes are actually going to look like with much more fidelity so that you can do scale to zero essentially as a primitive gesture. The scale to zero is the same exact thing in a Carpenter scenario as a scale from 3 to 5 of a, say, even
Mhm.
if you are on a homogeneous node pool, it's basically going through the same flow as far as I understand.
Yeah. Yeah.
So in the Carpenter case, what's interesting and what we want to figure out, I think in the near term, what we want to figure out is like at a high level, is this correct-ish? Is that we would essentially, so the part where we create a node claim, um, we have already determined, so we're alighting over a bunch of steps that Carpenter needs in order to create that node claim, as far as I understand.
Yeah.
So something is it fair to say that something in between Carpenter and step two when it creates a node claim, we have to be able to extend Carpenter to include knowledge of these DRA data structures so that when it observes a pending resource claim, it can figure out uh, what kind of node resource slice outcome to produce in that node claim so that when it creates the infrastructure and then the DRA drivers are installed on the resulting infrastructure. And that could be, we can talk about that in a second because there can be a couple of different ways that can happen. That
Mhm.
the outcome is that there's a resource slice that matches our expectation sort of in pre-two step, that can then actually schedule that pod with the resource claim reference.
Yeah, absolutely. I mean, so the output of Carpenter Scheduler is basically for a set of pods, this is the shape that this node claim needs, like a node launch for this node claim needs to be to support that set of pods. So depending on the resource claims that are associated with those pods, that will impact the shape of the node claim created by the scheduler. I think Yeah, that's going to be where a lot of the tricky details are. But yeah, depending on the target audience for this, like is the target audience, what is the target audience for this, I guess? Like,
Do you mean like what's the sort of user persona? Like, let's just say like an AI ML.
I
Uh,
more so mean like, is this for an RFC? Is this for,
like literally this slide.
yes, yeah,
This image. So I think I have a goal of being able to help out John and Bo
okay.
from the DR from Google to deliver a compelling DRA autoscaling talk that includes Carpenter. So the audience is going to be, let's say, naive to DRA and maybe naive to autoscaling. Probably more in the sense of like naive to how DRA and autoscaling fit together. So the
Got it.
story that I want to tell is a kind of uh, the story that I want to tell is that DRA was developed in part to address the operational challenge of how to optimally schedule workloads in a super complex multi-tenant topological cluster environment. So
Mhm.
you've got let's say, a large cluster environment with lots of different topologies. How do I optimally pack? So it's sort of similar to some of the problems you can imagine Carpenter tried to solve with bin packing,
Yeah.
using the sort of standard scheduling constraints. So the observation was made that in the GPU world, those standard constraints have sort of reached their limit. And so being able to define constraints like I need any GPU as long as I need as long as I can get n number of GPUs, and as long as they're on the same IO topology, then I'm good. Like that can tell the scheduler something like, well, we can target a particular H100, we can fall back to an A100, and there might be one or more InfiniBand connected um, uh, network topologies that are exposed. Potentially, those InfiniBand network topologies can like be elastic and dynamic, and in real time they can connect to other aspects of the cluster. So in these kinds of things, which are real problems that places like NVIDIA were facing in its sort of its cloud. So there are like KubeCon talks from Salt Lake City in particular that describe the challenges that NVIDIA faced in its multi-tenant cluster. So it's like serving a sort of retail cloud where you
Mhm.
can like rent GPU-enabled Kubernetes nodes. So at that scale, with that kind of multi-tenancy, uh, in a world where GPU hardware is severely constrained, um, finding sort of optimal packing is super important. And so they sort of talk through how they tried to do this with the existing Kubernetes API and how the evolution of the DRA API is sort of addressing that. So to
Okay.
get you back to your point about the audience, you tell that story like DRA is designed to um, allow for flexible topological constraints, like ideal, second best, third best, fourth best. You know, if all else fails, just give me this because then I can do some work and make some forward progress. That
Yeah.
kind of an idea. DRA is meant to address that. So what's cool about Carpenter is it actually, so the assumption in that case, so like that NVIDIA talk that I referenced, is we have a huge data center and we built out all this stuff, and now we need to figure out how to get all this stuff like in a sort of Tetris. Like we're getting all these Tetris pieces. How do we arrange them? In the Carpenter world, you build the topology as you go. So that's I think the story you want to tell in a DRA autoscaling talk in terms of Carpenter, um, is that you get to build the topology in real time. And
Right.
so using the sort of Carpenter bin packing uh, value add, you extend that. DRA allows you to extend that even further. So of course it makes the job of folks like us who are trying to implement this super hard because it adds way more complexity. But the idea is that DRA provides more sort of opportunity to take advantage of additional complexity, if that makes sense.
Yep. Yeah, no, that does. And that pretty much answers my question on target audience. The main reason I was wondering was like, if we're thinking ahead to writing an RFC and design doc for Carpenter, I think most of the interesting stuff is going to be in that step two, and then also how it works with consolidation. But if you're just
Yeah.
trying to tell the high level story of this is how DRA is going to work with Carpenter as an autoscaler, I think this tells it.
Okay, great. So I what do I need to do to make sure that I can give permission to Google to give this talk? Do you need to get like a thumbs up from?
Let me verify. I don't believe so, because at this point
Cool.
it's a Kubernetes 6 project. This is, I mean, yeah, if we started talking about how exactly it integrates with AWS, for example, for the AWS provider, maybe there would be something a
Yeah.
little more necessary, but I don't believe so. I think everything like with regards to trademarks and stuff for Carpenter has went over to the CNCF.
Yeah, I think I tracked that. I think that's true-ish. So cool. But
So
I think they're giving the talk on Monday or Tuesday, so we've got some time, and I
yeah,
want
I will
everybody to feel
follow up.
good about this.
I'll follow up just to sanity check, but yeah, I think that should be good.
Okay, cool. All right, great. Alima, does that all make sense? I know that I'm just
Yeah.
talking a mile a minute here.
No, I'm really excited. So probably after this talk and everything, next step would be to make the RFC and like actually break it down.
That's yeah. Let's talk about that. What's next steps?
Yeah, I think, yeah, like you called out RFC design doc. I think there are a couple of challenging questions that we need to solve, particularly how do we communicate to Carpenter what resource slices will be available for any given instance type. So I think we had discussed this already in Slack a bit. The one fallback mechanism we can probably use is node overlays and being
Yeah,
able to specify it that way. Um, and that doesn't necessarily walk us into a one-way door decision. You can always use node overlay as your fallback, and then we can expand with automatic discovery in the future, and make that like on a cloud provider by cloud provider basis. Um,
yeah. I wonder, do we? Let me see if there's anything I can share real quick. Well, in the earlier, if we look at the Slack thread, maybe we can just share that in a sec. At least if I can scroll up and find. We don't have to necessarily solutionize to death here. Is there? Yeah. So I'm gonna share this real quick. Let's see. Share. Always a fun journey sharing your personal Slack on a permanently recorded
yeah.
file. So wish me luck that I don't end up somewhere bad here. So I think this is an interesting. Can you see the screenshot?
Yep.
Is it zoomed in? Did
Yeah.
the zoom in work too? Okay, cool. So I think that that item starting with the key of basic, the object key of basic,
Mhm.
that's a device. And it's not strongly typed as far as I can tell from the DRA spec. So it's really going to be up to vendors to define their own type structures for various hardware architectures they're releasing, whether it's NVIDIA or Intel or AMD or whatever. So, but this is what I think this is this is an A100. It says right there. So this is what an A100 device looks like. So this is the key thing that's going to be necessary to fulfilling that request. So what Carpenter wants to do is it wants to build infrastructure and it wants to see those pending pods go running.
Yeah.
That's the transactional. That's like the terminal transactional state you want. So if we can build up similar to the existing sort of dictionary that Carpenter uses, like I think that's the node pool API, right? Which
Mhm.
allows various device. I don't want to overload the word device, but things like compute and memory, the mappings for various high level
No.
VM capabilities to the actual SKUs that can deliver those, so that Carpenter can then narrow its set of possible SKUs or instances to consider for launch, and then pick the cheapest. For example, go ahead. I see you're going to say something.
So yeah, I guess just the one caveat. So node pools, it doesn't really describe what the SKUs look like. It is a description of what SKUs you can select.
Yeah,
Um, the current like existing mechanism for describing what a SKU will actually look like would be the node class. That's kind of been our injection point up until now, though that's obviously cloud provider specific. We have our EC2 node class.
yeah,
Azure, I'm sure, implements their own node class, etc. Node overlay is kind of perfect for this because node overlay is our upstream mechanism for describing overrides for a SKU, saying this is like a set of SKUs I want to select on, and this is what that SKU will look like.
Cool. Great. I mean, the complicated thing here is I don't think there's an analog in the current world where we need to rely like this thing that got published, which would be able to fulfill. So we've got here the key things here are the device class name of gpu.nvidia.com and the count of 2. So maybe I don't know where that's defined here. It's somewhere it's in that device class matches with this device, and then uh the math for 2 is in there somewhere as well. But we don't have an example in Carpenter that I know of where the node itself is not going to carry the necessary metadata to aid the scheduler. What's going to happen is the node's going to come online, and then the DRA driver is going to be responsible for creating the actual resource slice, which is going to be the thing that actually allows scheduling to make forward progress. So I don't know if
Yeah,
Carpenter itself has any opinion about that, because there's lots of ways that can there's 2 main ways that can happen. One is that you assume the provider bakes into the OS image the DRA driver. Either it's already previously installed, or there's some kind of system D job or something equivalent that says, when I first boot up, go run the DRA drivers, which is going to be responsible for doing introspection that populates all that kind of device information in the resource slice, but also communicating with the Kubernetes API server to publish that resource slice, because it's like this is a custom resource.
yeah,
I think the more idiomatic way is going to be that you're going to have a daemon set on that cluster, and Carpenter is going to build a node that's going to come online with the sufficient node selector criteria that the daemon set is going to say, I need to replicate myself and put a pod on this new node that came online, which is then going to run through all the DRA driver stuff, which is eventually going to publish this resource slice. But all that stuff is like serialized in terms of Carpenter paying attention, because I assume Carpenter is aware I built a node to fulfill these pending pods, and I assume it keeps track of the forward progress and has a TTL, and if those pods don't go pending at some point, it might reap that VM or
yeah,
try. Yeah.
yeah. I
So
mean, this is
that's
already
to be all be accounted for, because that it's going to take longer for the terminal process in this case than it normally would.
Yeah, I mean, I think this is already a problem we kind of solved for existing like extended devices. Like using the pre-DRA way of using like GPUs. You have your NVIDIA driver daemon set, which publishes the extended resource onto the node after the node is initialized. Like the kubelet doesn't necessarily register with that extended resource. That's
Right.
where Carpenter's node claim like lifecycle state machine already models that today. I think it would be relatively simple to extend. If Carpenter expects a node claim to generate a resource slice, Carpenter won't transition that node claim to the initialized state until that resource slice is published.
That sounds fantastic. Yeah. Okay, cool. I don't think we need to go into excruciating detail. I think next steps, the normal next steps would be, let's create a Google Doc or something like that and just start drawing at a high level or describing at a high level what's going to happen, so we can, to a certain extent, narrate the slides we were looking at earlier, and then go to a lower and lower and lower level of detail until we get to the sufficient. We feel like confident that, like, okay, now we're talking about evolutions to node overlay, maybe evolutions to node claim.
Mhm.
I don't know if there's going to be evolutions to the core, but we can get more and more in there. And at some point, it'll matriculate to an RFC against the core repo, which describes all of our design conclusions. Does that sound like
Yeah, yeah, I
something
think
we can set? We could set out on like a 6 to 12 week journey to do that, and we can start more or less right away describing this in a Google Doc.
yeah, I think so. I will add I will be out for 2 weeks, not next week, but starting the week after. So I'd
Okay,
be
cool.
able to contribute for those couple of weeks at least, but definitely will be able to after. Um, and yeah, I think we definitely 6 to 12 weeks definitely seems like long enough that we should be able to, at the very least, get a design doc driven, if not get a good way with the implementation.
Yeah, well, that's super optimistic on the implementation side, but I'll take it.
Yeah, I mean, so I at least right now I'm planning on working on the implementation work on AWS's side. So
Okay, awesome.
yeah, priorities may change, but that is something that I'm looking at. That was the thing I was planning on working on next after I've
Okay,
been
cool.
a lot of work on reserved capacity. So
Yeah.
now that's wrapping out. Um, yeah, the one interesting thing, which we definitely don't need to go into now with 2 minutes left, is going to be how we deal with like resource slices that are consumed from a separate instance, like these network attached resource
Yeah,
slices.
no, for sure. We actually, I think we talked about, did we talk about that together or we talked about that with someone internally as well?
Mhm.
And that's definitely coming. Um, the Istio folks are talking about like how CNI and other things can leverage DRA. So like these things are coming.
Yeah.
Um,
That's the one thing. Everything else, I kind of see how it maps into Carpenter's existing model. This is the
yeah,
one thing that starts to diverge and raises a lot of interesting questions.
yeah, but I mean, it's kind of amazing to imagine a world in which Carpenter can actually serve non VM
Mhm.
infrastructure requests. Like that's kind of cool to think that
Yeah,
you could literally stand up a network topology using you have Carpenter installed on your cluster and you use sort of first class Kubernetes workloads to describe network topologies that don't exist and Carpenter goes and creates them. That's super interesting.
yeah, no, it's definitely a super cool problem space. I've been looking forward to getting to work on this for quite a while, so I'm definitely excited to get this kicked off.
Okay, cool. Yeah, so the device management working group talks a lot about the nuts and bolts of DRA. If you feel like you can make cycles, it's kind of early for us. It's 8:30 in the morning on Tuesday, just FYI.
Yeah.
I go to all those and I go to all the SIG nodes. And I'm SIG Autoscaling tech lead, so I go to those on Mondays super, super early. Yeah, just saying you're invited to all those if you want to learn more about all this stuff.
Yeah, no, I'll probably make time to definitely at the very least go to the DRA device management working group. I had went earlier on, but yeah, got busy.
Yeah,
So, but yeah, now that it's getting to be top of focus again, makes sense to start attending again.
cool. All right, yeah, we're at time and I've got another meeting I have to bounce to. Thanks so much, Alima, for sharing the slides.
Yeah, of course. Thanks for obviously presenting it and going through it.
I think you're probably going to do the Azure provider stuff. Just heads up.
Okay.
Look forward to that. I think it'll be fun.
I think so too. And it's good meeting you, Jason. We kind of met, but we haven't interacted, so I'm excited to keep working together.
Yeah, no, it's good meeting you. Definitely excited to have fresh people working on the Carpenter project.
All right, cool. Thanks, everybody.
All right, thanks.
Okay.